All right, here we have a position versus time graph that's curved. And whenever we have a curved graph, the slope of the graph is changing. So, for example, the slope of it over here at t equals 8 is going to be different from the slope over here at t equals 2. And the slope is a measure of the steepness of the curve. Now, how can we actually evaluate the steepness of a curve? One of the ways is to use either a secant or a tangent to the curve in order to estimate that steepness. So how does that work? Well, what we want to do is we want to pick 2 points that are close to the t equals 2 mark with which to calculate a slope. Now, one option we have is to create a tangent line, and all that means is we just want to make a line that's going in the same direction as the curve at that point. And then we can just pick one other point with which to calculate our slope. So perhaps I pick this point here and then this point. Notice I could also pick this point here. And if we can make a triangle here and just find the slope of its hypotenuse, then we'll have a good approximation of the actual slope at that time. So I see we've got the point 0, 15, and up here I selected the point 5, 40, and we'll just try to find that slope. So the m will be approximately 40 minus 15 over 5 minus 0. And that's going to give us, let's see, it's going to give us a slope of 5. And we'll put units on it, meters per second. So that's an approximation of the actual velocity at t equals 2. So I would put a 5 meters per second here. It's a pretty large value. Now let's try it one more time with the person over here. They're standing at t equals 8. So I want to do the same thing. I'll use a different color this time. And we'd just like to draw a tangent that has approximately the same slope as the curve does at that point. And I'll just make a triangle out of it. Pick 2 points that are easy to identify on the graph. And now let's calculate the slope of the hypotenuse of that triangle, right? So up here we've got the point 10, 40. And this point here has coordinates 4, 35. And we'll find the slope. Now, the slope could be called m, or in this case I'll call it v. It's a velocity, right? So the velocity will be 40 minus 35 over 10 minus 4. And that's going to be 5 over 6. So it's approximately 0.8 meters per second. All right, according to these calculations, what's happening to the speed of the object as time goes on? It's starting off with high values because it's steep, and then it's ending up with low values. The velocity is decreasing. We could also say that the object is slowing down. Now if we were to fill in values for time of 1 that would be right here, and you can see it's quite a bit steeper. I might guess it might be as high as perhaps 10 meters per second at that time. At t equals 4, we might be down to something like 2.5 meters per second. At t equals 6, perhaps 1 or maybe 1.5 meters per second. Then at 9, we're almost flat, so maybe around 0.2 meters per second. Now these are just estimates. It's not expected to be perfect here, but those would be reasonable guesses.